I'm Andy. I work for EngineerBetter. For those of you who don't know, we're a small cloud consultancy based in London. I'm sure a lot of you know DJ, our moustache CEO. So today I'm going to give you a brief overview on how I deployed a service mesh on top of Cloud Foundry. We'll explore some of the interesting bits of getting it running so that we can see all the features that we use to make it possible. And so even if you don't need a service mesh, hopefully you'll be able to take something away that might help you run applications better or using some new bits and bobs from Cloud Foundry. All the code samples can be found in the GitHub repo here. So if anyone wants to give this a go themselves or have any reference, you can check it out over there. So first and foremost, let's lay out the goals of what we're trying to achieve so we can assess how well we're doing. So first and foremost, we want our apps to communicate within the platform. A cross-platform service mesh would be cool, but I think it's probably let's try and walk before we can run. Secondly, we want to simplify the network from an applications perspective. Ideally, this means not having to configure our app to know about protocols, ports, or DNS. We'll also be able to secure network traffic between applications as part of this. Many Cloud Foundry foundations are multi-tenanted, and we may not completely trust the network over which we're communicating. So if we can lock things down, that's ideal. We're modern software developers, so we want everything to be in source control. So all configuration will be written down and applied as automatically as possible. And we will also not require any elevated permissions. As I said, we'll just be normal space developers as we do this. Lastly, and probably most importantly, we're just trying to show off some cool features of Cloud Foundry, especially some of the newer ones that you may not have used before or may not realize, and so that we can all enjoy the full benefits of this platform that we use. Also, just to set a couple of extra boundaries, given we only have 20 minutes, we won't be doing a production-ready deployment, and we're not going to do a big deep dive into how Consul works. We'll just be kind of seeing how the features of Cloud Foundry helped us out. Right, so to demonstrate service mesh features, you kind of need some microservices. I recently bought a Bosch release for Jaeger, which is an open source distributed tracing system. And as part of testing that Bosch release, I used the Hot Rod microservices, which are a set of 4 microservices that communicate with each other in a reasonably simple way, which are used for demonstrating how Jaeger works. But we can use them to show off some of the features of our service mesh. And to really drive home the point about the service mesh work, normally you can't actually deploy Hot Rod to Cloud Foundry as 4 separate applications, as they expect them all to be running on the same host. But I think we can fix that. So the first step in setting up a service mesh is choosing your software. If you ask most people these days which service mesh they would use, they'd probably say Istio. I think those people have probably never tried deploying Istio outside of Kubernetes. Consul from Hashicorp is an alternative service mesh that defines itself as a solution for service networking across any cloud. And it's comprised of simple and easy to use components, and it comes with a nice UI that's quite good for showing off in blog posts and conference talks. So we're going to make a slight amendment to their product statement and see if we can do this across any Cloud Foundry instead. So the basics of getting Consul running are that we need a control plane, which is 3 or more Consul agents running in server mode, which can store the state and the configuration of our mesh. Control plane also serves a nice UI for visualizing what's going on and checking the status of everything. The other piece of the puzzle, the Consul agents and the Envoy proxies, which run as sidecars to other applications that are part of the service mesh. We'll see a bit more about this as we build it up. So step 1 is deploying the control plane. As I said, this is just running the Consul agent in a special mode, which uses a -server flag. The Consul agent is just a simple binary, so we can just use the binary build pack to get this running. And then we just add a bunch of command line flags which tell us to run a UI and a server. We add a health check for the UI endpoint, and we run 3 instances as discussed before. So far so normal, other than this quite complicated app command. But there are these weird bits in here, these apps.internal references. So what are all these about? So that brings us on to our first cool Cloud Foundry feature, which is container-to-container networking. So this is sometimes known as internal networking, and it basically exploits the Silk CNI to allow applications running on Diego cells to communicate with one another directly. So by default, traffic is not allowed between applications, but we can create network policies using the CFCLI to allow either TCP or UDP traffic to flow directly from one application container to one application container. So historically, if you had 2 applications running on the same foundation and you wanted them to talk to one another, you had to go out via the Go router and use the public route. The Go router is a great bit of kit, but this is limited to HTTP and HTTPS, which may not fit all workloads. And that, coupled with the fact that you're having to go in completely through the front door, which may involve going all the way out to the internet and back in, maybe via load balancers or other networking middleware. And this is quite a lot of network connections, as well as like making it so that our traffic has to leave the platform just to come back in. So container-to-container networking allows us to go directly from an app instance on a Diego cell to another app instance without using the Go router. And this can happen over any protocol you like, since these are just TCP or UDP connections. The other key component here with getting this all working is the apps.internal domain. Container-to-container networking allows us to talk to other applications, but how do we find out how to address them? The apps.internal domain allows us to be discoverable by other applications running on the platform by binding to a root in this magic domain. Cloud Foundry will then automatically track all the running application instances and update the DNS for this domain, which provides a simple method of service discovery. I say simple, it's actually quite a bit more complicated. I really recommend going to see Toby's talk after this one about how Cloud Foundry goes bang if you want to know a bit more about how the system works. Another feature that we can use of this is that if we need to address a specific application instance, we can prefix the hostname with the index of that instance, which we'll see in use a little bit later. So as we discussed, we have the console control plane, which is 3+ console agents running in server mode. And then we can use TCP and UDP to access one another for meshing and using the gossip protocol to identify each other and sync configuration. And to do this, we need to be able to uniquely identify each instance. So TCP and UDP connections we can achieve with container-to-container networking. And uniquely identifying each instance, we can use the apps.internal domain and that index prefix that we talked about. So this looks like a pretty good candidate. So as you can see, we add another root, which is on the apps.internal domain here, and then we use index-based access to uniquely identify each of them when we tell the agent which other servers to join. What we can't see here is that we also had to create some network policies that allow communication between the console server instances on both TCP and UDP. Unfortunately, we can't do this through the manifest at the moment. There's no declarative way to achieve this. So just trust me that I did that. So if we CF push the manifest and we browse the public root, we're met with this screen, which shows 3 healthy server instances and a star indicating that successfully elected a leader, which is all nice and good. So stage 1's complete. We have our control plane, so now we can start building our mesh around this control plane. So to build a mesh, we need to register applications within it. The way we register applications is that we run these 2 sidecar processes within the same container. One of these is the console agent, which is configured to sync configuration down from the control plane and keep that all up to date. And we also deploy an Envoy process managed by Consul. Envoy is a highly configurable proxy. It's the same one Istio uses. You may have heard of it through that. And it can sync configuration via the local agent to make sure it stays up to date. So here is an example manifest of deploying one of those hot rod microservices we talked about, the front end of this situation. There's quite a lot to unpack in this situation. So let's just focus on one particular YAML key, which is this sidecars key. So this is cool feature number 2 that we'll get onto, which is that applications can now define sidecars in Cloud Foundry. Sidecars are an extra set of processes that run in the same container as an application. They're allowed to consume a fixed share of the application memory and can be configured either through the manifest, as we're doing, or by a dedicated sidecar build pack. Critically, all this means that they share a file system and process space, and for our use case, most importantly, they share a network space, so they can bind to the same network interface as the application. So here we can see the sidecars defined for the hot rod front end. So we have the console agent, and you can see we are joining it to the control plane that we defined in the previous steps. And then we also get Consul to start this Envoy proxy up for us. There's a little 5-second sleep in there due to a race condition about the Consul agent having to be running before we start Envoy, but other than that, all fairly normal. The last kind of big interesting thing here is the config directory. So what's going on in here? So I'm not going to do a hugely deep dive into configuration for Consul, but this is effectively what that configuration looks like for an application. We define which service this represents, and then we add any upstream services with which we want to create proxies for, and these bind to a local port, one per proxy, and that allows us to communicate with other services in the mesh. So if we set everything up right, and we push all of those 4 applications, the front end, customer, driver, and route, we should be able to see all 4 microservices registered in the service mesh, and they all look healthy, which is good. If we do a bit of a deeper dig into one of them, we find the hot rod front end, and we can see that those 3 upstreams that we defined before, those are all running those proxies on 80, 81, 82, and 83. So earlier we saw this diagram of the 2 options that we have by default Cloud Foundry for communicating between applications. And what we've done is we've augmented that by adding the Envoy components managed by Consul. So we can see that the Consul agents are syncing data down from the Consul servers, and the Envoy sidecars are being configured by those agents. Traffic between services passes via both Envoy sidecars. And so earlier you may recall me saying that you couldn't normally deploy Hot Rod to Cloud Foundry as it expects all the services to be on the same host. But now we can see how Consul has helped us get it working. As the Consul proxy is on the same host as each service, then from the front end's perspective, it looks like the backend services are running locally, with Consul and Envoy quietly handling all the hard network bits in the background. And as an added bonus, the communication between these Envoy proxies is actually secured by mutual TLS, meaning everything is encrypted without the applications even needing to know about how to do encryption. So everything should work in theory, but if we try to actually order a ride through Hot Rod, we find that it just hangs on dispatching a car. This is because of the Cloud Foundry deny by default network policy. So our sidecar proxies can't actually communicate with one another without us creating some specific network policies. But in a service mesh of many applications, we need to ensure that network policies exist between all of them. So how do we do that? Well, that leads us on to the third feature that I want to talk about, which is metadata. So most objects in Cloud Foundry can have metadata associated with them. Kubernetes users, I'm sure, are fairly familiar with the idea of labels and annotations, but you may not have known that you can apply these to apps, spaces, and orgs, amongst other things in Cloud Foundry. And we can use this to mark specific environments, timestamp certain operations, or add commit hashes to pushed apps. We can use, in this situation, a label to mark all of the applications that should be part of the service mesh. And this then allows us to write some scripts which fetch all of the applications within the service mesh, and then we use this handy Ruby permutation function to ensure that there's a network policy that exists between every pair of services in the mesh for all permutations of it. So now if we go back to Hot Rod after running that script and try ordering something, we confirm that everything is working as it should. So we have a front-end microservice talking to all of its 3 back-end microservices using Envoy proxies deployed and managed by Consul. If we quickly revisit our goals, we can show that we've met all of the criteria by communicating within the platform, not requiring applications to know a lot about network topology. All of our traffic is now secured, and we're using declarative JSON and Hashicorp configuration languages files to manage everything, and we don't require any permissions more than a normal SpaceDeveloper. So thanks for coming, everyone. I know that was a bit of a quick blast, but I'll be around now for questions, or feel free to reach out to me during the rest of the summit or in the Cloud Foundry Slack if you'd like to discuss more. Thanks. Hello, everyone. I see there's one question in the chat on the main session, so I'll answer that first. Says, are there any limitations to the number of Go routers needed to implement the Envoy proxy? So one of the really nice things about this is that actually the Go routers aren't really involved. There's still the core component for doing ingress into the cluster, so accessing the front end, for example, but all service-to-service communication actually travels just over Silk, which is just a CNI, so all it's doing is configuring some network policies and IP tables rules. So there's actually no extra networking components like a Go router. The Envoy proxies are the limit of it. So you don't need to scale your Go routers at all. In fact, if you were currently using the Go router to do service-to-service communication, you could probably remove a lot of that traffic by using an internal networking-based system. So it may even allow you to drop the number of Go routers. And as I say, it supports other non-HTTP protocols, so uh, it's got some other benefits to skipping the go-routers as well. I hope that's answered your question. Please let me know if you'd like any more clarification. I haven't got any more other questions at the moment, so if people want to send some over or stick them in the chat, then feel free. Ah, will there be a blog post? Excellent question. So this is actually already up. I blogged about this a while back on the EngineerBetter blog. I'll put a link actually in the chat so that everyone can find it. This is basically something that I thought about as a due to going to a talk at the last summit, the NA summit, and Jonathan Matthews, who's a friend of EngineerBetter, kind of said something that piqued my interest about using non-transparent proxies to build a service mesh. And so one day on a bench Friday, I played around with Consul and then wrote this blog about it. And I thought I'd give a talk at this summit so that people could maybe get a bit more of a visual basis. But in that blog post is a GitHub link as well that should have all of the examples and all of the code that was needed to do this. Obviously, I wouldn't recommend running it in production in its current format, but it should show you what you need to do and let you play around. It's a dedicated repo, so if people want to ask any questions or play with things, then feel free to raise issues on there. Or, as I say, you can always reach out to me on Cloud Foundry Slack, and I'm normally around. So, yeah, 20 minutes is quite short. So, if people want a bit more time to play with it, then feel free. Good question. So I'm not sure if I answered that at the beginning of this breakout session, but I'm not sure if people had transferred over yet. So the answer to do you need more Go routers is no. None of the communication between service to service acts via the Go routers. In fact, the envoys are the limit of the networking infrastructure needed. There's the Silk CNI, which does some things with IP tables and network policies, but that's all part of the infrastructure itself. You don't need an extra component. You don't need to run anything that's any in your processes. And in fact, you could arguably scale down the number of Go routers as well, saying as if you're currently doing out-to-out communication via the Go routers, via the public routes, by switching to an internal networking model, you could actually save some traffic going through the Go routers that doesn't need to. And as I say, it opens you out to being able to do other TCP-based protocols like gRPC, or you can do UDP-based protocols. I've used it for things like StatsD in the past, which is a UDP-based metrics protocol, which can't go via the Go routers due to it being all UDP-based. And as I say, any TCP as well without using the TCP router. It's all right. I don't know if anyone else is here, so I'll just no harm in repeating it. Right, I've got about a minute left, so any last questions or we'll stop for, I think, stretch and back exercises and things, something like that on the schedule. Is Daniel Jones a good boss? Yeah, generally. As long as he's not writing code. He'll agree with me on that one, I hope. Oh, pickle, for sure. Yeah, I love fermented food, so definitely pickle over jam. Cool. I feel like we've moved a bit away from service meshes, so I'm gonna end that there. Thanks for coming, everyone. As I say, if anyone wants to reach out either through the Summit platform or via Cloud Foundry Slack, feel free, or GitHub issues. Thanks for coming.